What's new in Java 23 and why should you care about it? Find out from the best leaders and experts who are closely involved in creating these new Java features and the ones who will help you to use them. In today's episode of JEP Explained, we'll cover JEP 466, which is about using an API, that is class file API, to parse, generate, and transform Java class files. So, what about it? Why do you need an API to do all this? But wait, this is a new Java feature. So, what have the developers been using until now to parse, generate, or transform Java class files? We'll find out answer to this question and much more. Get ready to discover what you have been missing all these years. Hi everyone, I'm your host Mala Gupta from JetBrains, and to talk about class file API, we have with us today Rafael Winterhalter, Java champion, consultant, blogger, speaker, and author of Byte Buddy, which is a runtime code generator for the Java virtual machine. Hey Rafael, it's a pleasure to have you with us today and talk about this topic.
Likewise, thanks for having me.
So, Rafael, I want to start by asking you an interesting question. So, your intro mentions that you are a software consultant who likes static types. That is really interesting. Why does it define you?
Well, as anybody working with software knows, there's a lot of strong opinions about what good software is, and it's just I'm a business consultant, so obviously I have my perspective on things that isn't everybody's perspective, but to me, it's an essential feature of a programming language that you use for professional software development, and I was never really attracted by many of the languages that the young kids enjoy working with, like Python or JavaScript. So that kind of always was my property that I had to discuss with my colleagues. So kind of that's why I guess I have it on my biography today.
And I think that's one of the strongest points of Java as well. So that makes sense.
Certainly, yeah.
So, Rafael, before we deep dive into the details of this JEP, which is Class File API, I want to ask you, why do developers even need to generate or transform a Java class file?
Well, that's a good question because most Java developers will never do this themselves, and it doesn't seem like it that it's like a very omnipresent feature in the JVM. But any Java program is creating dynamic class files, and that's starting with the JVM that is creating Lambda expressions. For that, it creates implementations of interfaces at runtime. That's what it does, or let's say Hibernate will create proxies, and in order for the proxies to know to that you call the method that you change data and that you have to flush some state to database, it needs to kind of add some code. And that's exactly why the JVM needs dynamic class generation, is because it is static, but it wants to add some dynamic features. So these features are in a way locked behind a door that is dynamic code generation, and that's why it's important for people to at least understand that it is there and why it's there.
So I think we are talking about a lot of applications that would be working with this. So could you help us with some examples of the applications or the libraries which perform these tasks? I know you just mentioned Hibernate. So are there other frameworks which use this quite frequently? My intention for asking this question is how relevant is for all Java developers?
Well, it is relevant for Java developers that want to create frameworks. It's not normally something that you have to create when you write end user code. And the reason for that is that you do not normally need to write very generic code. But let's say you want to implement a mocking framework. That's something I work with a lot. I'm on the Mockito team as well. So there, in order to basically being able to take any class and make a mock out of the class, we have to take the class and then we have to um, basically redefine the method to not do anything. And if you owned the source code to this class, you could just add some logic for it in theory and recompile the class. But you don't want to do this for like, or you cannot do this for classes you do not know when you write the framework. So in order for that to happen, we have to basically create a mock the first time that we discover the class in question, and that's at runtime. And that's why we need to do dynamic code generation. We cannot use the Java compiler to create the class file. We have to do it using a library. And in my case, often that's Byte Buddy. That's the library I wrote. And that's what it's used for.
That makes sense. So the developers who are working with writing all those frameworks or libraries, they need to know the details. But I believe from what you said, all Java developers should know a bit about how it works. Am I right?
Exactly. Exactly, because if you debug your application that you run in your
Mhm.
production environment, let's say you have a Spring app will also create proxies for your configuration classes and so forth to install its own hooks. And if something doesn't work as intended and you want to understand why, and you will set a breakpoint somewhere and or like look at a heap dump, you should understand what these things are because, of course, in order to understand what's going on, you have to walk through everything that your app contains, and this will be also partly proxies. And if that confuses you, that might distract you from finding the cause of your error. So that's why I think it's important to be transparent about it and not just hide it away. So despite you not having to create these proxies or to redefine code, you should be able to reason about what's going on.
That is interesting and makes a lot of sense. So, what are the possibilities when we talk about the transformation of a Java class file? What kind of transformations or generations are available? Are we talking about adding, deleting, modifying methods, variables? Maybe can we alter the hierarchy? So, I'm asking a kind of an umbrella question. So, what is allowed but should not be done, and what's an absolute no, like kind of risky to do?
So I think the most dangerous part about class generation is that sometimes it's overused because it's like an approach that people understand. So it should be a last resort. But when you need it, typically you need it because there is no alternative. The most common form of code generation is certainly to create subclasses where you just create classes from scratch. And then basically, because the JVM has virtual methods, you can intercept calls by overriding methods at runtime, right? So you create a new class. Uh, that's the first biggest class of tools. The second class of tools is typically Java agents. That's code that injects itself into your code. Like if you use something like OpenTelemetry, they will use a Java agent often, or performance monitoring tools, New Relic, all these dashboard oriented monitors. They will basically just inject it themselves, and the goal is to not create much overhead and to not be visible in the best case, because otherwise you will be very confusing. The JVM itself is very restrictive of what you can do at runtime. So it is, for example, not possible to change a loaded class and remove a method. That's simply not allowed. There is a JEP for that as well to allow this in the future, but I think the JEP has been around for 15 years. I actually would have to check if it's not closed by now, because I've asked often in the past if that's still a goal for the Java virtual machine to allow like full redefinition capabilities, but I don't think it is. To be honest, it can also be quite confusing. Imagine you debug a program where some tool just randomly deletes methods. So in theory, I think that's just not a good idea. Adding methods also is restricted, so you have to play around, but that's what tools like ByteBuddy help you with as well, to not make you think much about what's a good idea and what's not a good idea, and just give you basically an API that allows you to do the things that are possible and hopefully guide you in a direction where you also do the things that are recommended. But once you use a high level tool, um, then you will not have to ask yourself the question. If you use a low level tool, hopefully you already know the answer to the question before you start using it. But that's like a small community as well. I don't know. Yeah.
So, Rafael, you just mentioned that these things are kind of overused sometimes. So, what are some of the patterns that you see which could be avoided, but they are kind of used in a way they should not be used?
Yeah, it's often the root reason that people start using code generation is that they kind of create a bad type hierarchy to begin with, and then they try to patch it up. Or like, let's say you want to have a listener that is called upon every invocation with some data infrastructure, and then you have like a huge API that can interact with this data structure, but you have no central point where all the calls go through. So instead of having like a manual listener invocation somewhere in the background, you just start adding it by code generation to all the methods that exist. Then the right solution would have been that you refactored this API. Maybe that's not possible. So sometimes you need to use code generations to simply make it manageable to maintain old and poorly designed code bases. But of course, the ultimate goal should then also be that you refactor at least eventually, because otherwise code generation, especially for beginning Java programmers, can add a layer of complexity that make it very hard to understand what an application is doing.
That's an excellent point. I'm wondering if you already have a list of such practices where you have published something on that part. So share the a link with us if you already have, and we'll
Yeah,
add this to the interview.
yeah.
That's good.
That's
So
the thing about being a consultant, right? So hard to sometimes say if someone wants to hire me in for code generation, to say that's a bad idea actually. But I try to be honest about it. I still have enough work to do otherwise, so I can be honest about it. But yeah, people Google or Jet GTP their way to a solution, and then sometimes code generation pops up where it shouldn't.
right. So now I want to talk about Byte Buddy. You are author of Byte Buddy, which is the runtime code generator. So what have been the challenges with this application? And I would also want you to talk about the class file format because we know that it keeps evolving. So how does that affect your code and application?
So yeah, that's actually the last years have been much easier than the first years. But I'm lucky enough that ByteBuddy was mostly in the zero dot version range when Java 8 came out, for example. Because Java, the language, has evolved a lot. Obviously, I started ByteBuddy then when the latest release was Java 7. Um, but I already saw Java 8 on the horizon that, for example, allowed me to design the ByteBuddy API already around functional interfaces. And while they're not officially functional, because they don't have the annotation, you can still use ByteBuddy very much in a functional manner with methods that are lambdas. But yeah, so of course I cannot predict the future, and I guess nobody in the JVM team knows today how Java will look like in even 5 years. So sometimes it is hard to keep maintainable the backwards compatibility. But so far, since Java 8, most of the innovation in the JVM has happened inside of the JVM. The class file format, on the other hand, has been rather stable. Um, there was new constant types introduced, like constant dynamic. There was like nest types were introduced and so forth, but there were no like major changes to the bytecode format. This is partially because the bytecode format is limited. You have only at a maximum 256 bytecodes, and around 200 of them are taken. So you have to be careful when you add new features if they really make sense. And then there's a tendency to make things more, move it more to the JVM, so like the dynamic, invoke dynamic and constant dynamic. So the bytecode format isn't so much of a concern anymore, and it's anyways the JIT that does most of the optimization. So it's not that risky to do that either. And of course, I will have to see like value types at some point. There were discussions about introducing a whole new set of Q types, so-called Q types, to represent value types on the bytecode level directly. That would have been a massive project for me. But all in all, it's been quite easy since Java 8 to keep up with the bytecode level.
I also saw one of your tweet in which you mentioned about using the class file API. But as we know, this is a preview feature. So
Mhm.
how does that work? Because we know that the preview features, they are permanent features, but they could change in the next Java version. So how do you see the users working with uh, features that you are using in your product, which is a preview feature? How would that change? How would that affect the users in the next Java version?
So Byte Buddy traditionally is like it's when it's loaded for the first time, detecting the current JVM version it's running on, and it will then anyways extend its feature set based on the version. So like if you run Byte Buddy on Java 10, you will have very much different internals than you will have on Java 6. And the reason for Byte Buddy still supporting even Java 5 is that a lot of tooling vendors use Byte Buddy. So it's a lot of Java agents, and they often have to support legacy infrastructure of banks and so forth. And banks and insurances tendency is that they don't update all of their stack. So there will always be like these old apps that just work just fine. They're stable. They're fast enough, and nobody wants to invest money into touching anything. And if you upgrade an app from Java 5 to Java 8, if you've ever done that, or even to Java 9 with the module system, then and later, then you will have a lot of work that a lot of people want to avoid. And I think that's fair. I mean, I'm a consultant. I know that you have to really count your cash. And if you do everything like you do it in open source, then that would be way too expensive. But if you, for example, want to monitor your entire server farm of Java apps, and there's just one Java 5 application in the middle, and you want to do something like open telemetry with tracing data generation, right? And if you only miss this one app, then your graph will be incomplete. In worst case, it will be divided by two if that's like a central focal point. So there's a need to be backwards compatible. Having adapted this concept, it's pretty easy for me to say, all right, this will only work in Java 22. And if it's not Java 22 exactly, it won't load. When it comes, or it will be disabled. It will just give you an exception saying this JVM doesn't support this feature, or it will return you null if you've tried to resolve something. Then you can go on do something else, right? With the class file API, now I only opened for adapters because in Byte Buddy doesn't do the class file parsing itself. It's based upon ASM. ASM is a very mature, very good, and very performant bytecode parser and writer, but it is not more than that. It will just give you raw data, strings basically, and integers for every method. You can compare it like to a stacks parser for XML, and then Byte Buddy maybe is Jackson on top of that if you like relate to a library a bit more closer to most people. And but since ASM is doing these things that it does very well, Byte Buddy, or I chose to expose those APIs also in Byte Buddy. So ASM is part of Byte Buddy's official API by design. So I cannot and will not change that because I think it's a very good API also for those who want to do low level, high performance instrumentation. But what I did on the side now in a separate project is that I implemented visitors for ASM that read class files and write class files using the class file API. So basically, the JVM is now able to parse a class file with its own API, with its new API, and then translate it into the format that ASM would present me today. And then I can pass it through ByteBuddy all the way. And then in the end, I emit the data back to ASM as I do today. And then ASM isn't used to writing the class file again. It is, again, the class file API, but using an adapter. So that's the only thing I added for now. And then I have like an experimental branch where I use ASM directly. And I use that mostly today to test out the class file API. And I've found a row of bugs as well that way. So basically to contribute this way and also to give like feedback what is not currently possible with the class file API that is possible with ASM, because of course there's a lot of code out there using ASM today. So and I don't see everybody migrating the API. So I think this is a very straightforward approach to maybe adopt the class file API without rewriting everything. And that's kind of, I made the way for Byte Buddy to already do this. So if you wanted to write the adapters yourself, you could already do it with Byte Buddy 115.
That's excellent, because we don't see a lot of developers using the preview features in the production version of the code. And because you said you're doing it, you have a separate branch for it. I think that's amazing. I think the team who's working on this JEP would love the feedback that you've already provided with them. So thank you so much.
Mm.
That's really amazing.
Yeah, no, I mean, that's kind of also the most fun part about developing a library, is to try out new things, and actually having a use case for it makes you feel more useful than like doing everyday programming every day. Hmm.
Absolutely, the fun of programming. I completely agree with that part. I wanted to ask you about what would happen to the current process, as you mentioned about ASM a little bit in your answer. But before that, I want to ask you, what are the pain points that class file API had? Because you mentioned that you had you worked with it in your project. So how was your experience?
So I think the main motivation for this JEP and the class file API is that the JVM needs to create classes itself quite a lot as well. Like I mentioned, lambda expressions. And every time the JVM introduces a new feature, that like in the JDK version, then it will need to basically wait for ASM to adopt that feature, because as of today, the JVM is using ASM itself. So that kind of it becomes a catch 22, right? Because the JVM cannot use a new language feature in ASM before it has released the language feature. So basically, the internal usage will always be one iteration delayed. But if it then means that in theory you would have to wait always, like even if you could benefit of the language feature you just introduced, you would have to delay it always one version, or you have to patch up ASM internally, which is the scenario today. So that's kind of painful. Also, ASM is in a way, it's very efficient, it's very fast, but it is also old in the sense that it's not helping you a lot. It's made for performance, and for many cases, that's not the most important feature. So you kind of want more expressivity or more, readability of code, and make it easier to maintain. So I think that's also something that JVM tries to address. I don't think it's about competing with ASM, which is the intention, but it's about creating a tool for the JDK primarily. But of course, since it's every tool has the same problem, whenever the JVM updates one version every 6 months now, all the tools have to update ASM. And even if the class file format doesn't contain anything new, it won't work before you just allow for the new class file version to be parsed. So that kind of creates a delay. So the hope, I think, of the JDK team is that once the reading and writing happens through ASM, there will be more seamless upgrades, and it's easier to update the JDK because everybody can just use the same libraries on the same JDK, and then you can, of course, still upgrade the libraries later, but it's always painful to make it mandatory. And then especially if you have like a hard upgrade that there's actually changes in the library, then it's difficult to basically combine the two, and will take you more time to do two simultaneous updates and to do two fully independent ones. I think
Right.
that's what it's about. Yeah. Hmm.
So I think your answer already covered the other question that I mentioned about the current parsers. You already covered a section of ASM in your answer. Another question I would want you to answer is, what have been the benefits of class file API that when you used it now in your code?
Hmm.
What were the benefits?
So ASM already has like two offerings of API. One is like a visitor API, which doesn't really allocate objects. That's the one I based Byte Buddy upon, because a big goal of Byte Buddy also is to not allocate many objects. So Byte Buddy will allocate objects to create a transformer, and then the transformation itself will be very careful about allocating. With the class file API, the big difference is that it creates a lot of objects. So it basically creates an object for every instruction. That is very convenient to work with, but ASM also offers something like this. Yet, class file API, very modern API, you can use a lot of switch case statements and then basically make type checks on every statement, and then you can basically just jump through where you want to do it. Also, transformations are super easy. I find the two APIs, yet I find them very inspired. So the class file API certainly took the good parts of ASM and then built a bit convenience around it. It makes it certainly easier to learn and to use. So I think the learning curve isn't so steep anymore. Then again, that wasn't a real life problem since it's a pretty niche thing to do, manual bytecode generation, and Byte Buddy will likely not change, but I certainly think I can offer like wrappers, unwrappers also. So you can basically make it easier for people. But reason everybody could have created a new class file API that is more convenient, maybe to the cost of performance, to compete with ASM. The reason nobody did it is that there was no big demand for it, I think. So the JDK class file API really is about solving some of this forward compatibility issue that as of today, if you use the latest Spring version, the latest Hibernate version, the latest Mockito version, you will still not be able to run that on an early access version of Java 24 today, for example, because none of the frameworks support Java 24. Because all of these frameworks use ASM, and ASM doesn't support Java 24 today because Java 24 isn't released, and you cannot release an ASM to support Java 24 before Java 24 is out, which basically destroys the idea of early access releases, right? This is an actual problem that needs to be solved by having a class file API in the JDK, which is something we will have. Yet, once the class file API adds a new feature that is an actual new feature, then all the tooling vendors will have to adopt this new class file feature anyways. So this problem isn't really solved either. It will be solved for releases that don't contain any real changes in the class file format. And that's maybe good enough. So I think, yeah, to basically what is the main goal of the OpenJDK team with the 6-month release cycle. This was kind of defeated by ASM not being part of the JDK. Now we have something like that. So I think maybe in 2 or 3 years, when people at least fall back to class file API ASM adapters or use the class file API directly, it will be much smoother for everybody to upgrade the JDK. That's going to be the main and I think only visible benefit of the API. I don't think a lot of people will jump upon using it, which is a good thing also, because normally you shouldn't, as we discussed in the beginning.
So, because you answered about the current passes was kind of in a lot of answers, um, uh, do you think you would like to answer what would happen to the current passes as a separate question?
Oh yeah, no, certainly. No, I don't think, and I don't hope
Mm-hmm.
they will go away. I think
Mm-hmm.
ASM needs to continue evolving, at least as an API, even if they want to retire their internal parsers. But the API is so omnipresent now that it just needs to be retained in there. Worst case, I would add it to Byte Buddy directly, because just Byte Buddy has written a long range of ASM code. Rewriting that wouldn't be doable for me, like time wise. I would have to write a new library. Everybody would break the API, and ASM is so spread and it's so complex code that is written on top of this API that removing ASM in the next 10 years even would blow up the library space to some degree. So I don't think and I don't hope that it will have any impact on ASM. And quite honestly, ASM is a pretty, like, if you really want a high performance bytecode generation, then you want to use ASM and maybe fall back to the JDK. because of all the code, the object generation that I mentioned. Like I already ran some tests. If you like if you manipulate tens of thousands of classes, or let's say a JetBrains, right? You parse class files all the time. You index them. Indexing is certainly not the fastest path of an IDE either. So if you do all this indexing now while generating 50 times as many objects, will take even longer. So there's a reason that you probably want to use the fastest possible solution, even if the code will be a bit more messy. So I don't think. I mean, ASM has dominated the code, bytecode space for parsing. And that was BCEL for a while, but nobody uses that anymore. And it's so deep in there that I don't think it's going to go
Mhm.
anywhere.
That makes sense. It's not easy to change any existing code base which is already working okay. So yes, as you said,
Exactly.
both are, yeah.
And it's a JVM philosophy in a way, right? That's kind of the
Mhm.
reason also why it's so successful in business, is that you can use this old code base and drop it on a new JVM and it will just work. And the class file API is trying to improve that to make it even more compatible, because this is now not always true for code generation containing libraries. Um, if at the same time that this class file API was introduced, ASM would disappear, I think the effect would be the opposite for quite some years, because then a lot of people again have to change their code and have to uh, um, yeah work with upgrades that go together, right?
And that makes sense. Having everyone change their code base is
Mm.
definitely not going to work. It's going to have a negative effect instead of a positive one. So trying to balance out things and picking the one where one offers more benefits over the others, I think that would
Mm.
be the best way to move forward.
There's also another kink to it, because a lot of people that write code generation tools, if the JVM introduces a new class file feature, then this feature will be introduced in the class file API of JDK 27, right? If you want to use the Java 27 API, then you will have to compile your library to support Java 27, but then you cut off everything before. So with ASM, ASM is like Byte Buddy, still compiled to Java 5. You can just upgrade ASM. And then after that upgrade, you can run the library on Java 27 and you can run it on Java 5, which is a pretty essential feature for Java. So I really think this will, like, you can work with multi-release jars and everything. That's what Byte Buddy in a way does, right? It's talking of these feature switches, but it's complicated and it's not very accessible still. So just for that, I think ASM is still a pretty strong competitor compared to using the class file API directly, because you can just jump on new features without making all your fuses upgrade. And it's especially painful if the upgrade version isn't a long-term release version. I know most of my customers, they're not even allowed by the operations teams to use these JDKs in production, because there's no agreement with Red Hat or whoever they have a license with to support a version like that.
Right, that makes sense. So before we move on to the fun sections, if there's anything that you want to add to
Hmm.
this step.
Yeah, I can only tell people to try out these preview features, because there, of course, there's bugs, there's things to improve, and if you use something actively, and there's many APIs that get introduced this way, then you will find things, and you can actually make. Yeah, I have good experiences with reporting things, because you will actually be reacted to, and then the changes come out pretty much after, and you'll have a lot less pain using APIs that are finalized compared to using APIs that are in preview versions when you can still complain. You won't get so much response if you complain about an API once it's out and final.
That makes a lot sense, and
Mm.
more for the preview language features, because unlike an API where sections can be deprecated, for the language features, none of the parts can be deprecated. Once they get into they become part of Java, they are there forever. So this is what we talk about when we talk about preview language features. Like, you have to try them out now and let the team know what your experience is, and if there are any changes you want that to happen, please provide the feedback. So thank you so much, yes, for saying that again. So now moving on to our fun section. So the first part is, I have a tongue twister for you. I would display that on the screen, and you would have to say that aloud. You cannot be very slow, because in the past we had speakers who would say that very slow and they would kind of win. So you have to be okay with your reasonable with your speed, and your time
Okay.
starts now.
Okay. Byte Buddy juggles jumbo jet class files, transfiguring, transmuting, transmogrifying, transcending, transposing, translating, transitioning, transshaping, translocating code for the JVM.
Oh my god, that
The
was
non-native
all.
speaker advantage. I don't even know what half of the words mean, so I can just say them.
That was amazing. I did not expect that. So full points to you.
Thank you, thank you.
So the next section is, I would show three statements to you, and you have to react them using emojis, which you cannot type out. You have to enact those emojis. And once you are done enacting with those emojis, you have to tell me what the emoji was. So, you ready?
Not an emoji person, so I don't know any, but I think I know the basic ones, so I have to work with these then. Yeah.
Okay, so this is your first one. Java 23 is about to be released.
Yeah, I guess that's the I don't really care much emoji.
Oh my God. I was
It,
not expecting that reaction.
it's nothing that I'm super excited for about in that one. But that's just me, I guess. I'm of course interested and curious, but it's yeah, I push for features that I have important things. Upgrading JDK is not for code reasons, but for bureaucratic reasons. Is still a pretty big cost at my customers. So that one I'll probably skip for the most.
Okay, fair enough. So the next one is, maintaining an open source Java project is no problem.
I'll try the sleep emoji because that's where the time is cut out. So it's not a problem, but it's exhausting still. So
So do you get demanding users who are kind of asking you to create new features, add new features, and
hmm.
saying, it's just a little thing and you can do that?
No, it's not really. I The reactions are very positive, overwhelmingly. I
Wow.
never had these problems that people go on social media on about, but it's more like occupational pride that ruins me. That I want to have it done and I want to support it the moment it's out. And then if I don't really have time, I have to make time, and that's not always the easiest to juggle if you have other things like kids and customers, which are
That's interesting and good too. And the last one is, presenting at Java user groups is fun.
yeah, it's a thumbs up emoji. That certainly is, and that's kind of I prefer sometimes user groups over conferences because you get audience that actually wants to hear your stuff, and I'm not like, oh, I already watched 5 talks and now I need a place to sit while I eat my sandwich kind of people. Which is also fine. I mean, please come and eat your sandwich in my presentations. But it's yeah, it's more focused. Mm.
So I started with my speaking thing with a user group. So I'm all in for the statement. And of course, presenting at conferences is a different kind of fun and excitement. So yes, for me too, it would be yay.
Mm. Yeah, and you get time to talk much more. People don't run off to the next session or beer sales, whatever it is. Mm.
I get that
Yeah.
part.
I once at Java 1, I remember I had like 300 people in the room, and then half an hour in, 250 people left simultaneously because they had to go watch Bruce Springsteen or whoever it was. Elton John. It was Elton John.
Wow.
couldn't compete with Elton John. People had to get out to Alcatraz on the bus. Didn't want to be
Mm-mm.
in the last row, so I had to
Uh,
suffer. That was a pretty bad experience. Doesn't happen to
in-
you at a user group meeting.
Interesting. And
Mhm.
unless you have a similar show in the next building. No, no, no. I'm kidding. I'm kidding.
Yeah, right. That can happen. But
Yeah.
then at least
Yeah.
people will tell you. I wasn't informed about that. I found out later.
Mm-mm.
Like, what did I just
Mm-mm.
say? Mm.
Right. So, Rafael, thank you so much. It was an interesting conversation, and thank you for your insights about the Java File API and comparing with ASM and everything that you said about both of these, and of course, Byte Buddy, how that works, and for trying out Java File API in Byte Buddy, because that is something that a lot of developers do not do. They kind of wait for it to be a production feature, or they wait for um, other JDKs to come out, the long term support. So thank you so much. It was a pleasure to talk with you. I learned a lot. If you have any closing remarks before we
Oh,
close it.
thanks for having me, and good that you take initiative to shed some light on it. I think
Mhm.
it's gonna not be a very big visible change, but it's gonna be something that we all benefit from. So good if we get it
Mhm.
right, and I think we're gonna get it right, or
Mhm.
Oracle's gonna get it right. Everything
Mhm.
looks quite well to myself at least.
Thank you so much. And for everyone watching, keep watching because we have a lot of other interviews coming up. We'll talk about other Java new features which are coming out in Java 23. And until then, bye bye.